Hi guys, welcome back to my channel. This is the day one of DSA bootcamp. I will be starting GFG portal and starting with a problem of the day. And today the date is 8 July 2024. The problem is search in a rotated sorted array, and I will be starting with that problem itself. Yeah, as the question given, it was difficulty in category of medium category, and that's fine. And we have to read the question first, and we have to understand, and then uh, we should try and few examples to get what problem and which algorithm which is suited, and then we are start coding up. Whenever the interview given this question, you have to read the question thoroughly, as it mentioned that let's start reading the question. The given is sorted in ascending order and rotated array of distinct elements which may be rotated at some point, and the given element target key. The task is to find an index of the particular target element inside the array, and which is in rotated and which is in ascending order also, which is sorted. So this is the question, and uh, for a few samples, I will be dry erasing here. As you can observe that the given array, which is in rotated in fashion, because 1, 2, 3. After that, the rotation starts from the starting of the node, and it goes towards the mid. 5 to 5, 6, 7, 8, 9, 10. Yeah. So this is a rotated and which is also in sorted fashion. And we have to find a target key is nothing but 10, and which was lies here. And what was the index? 0, 1, 2, 3, 4, 5. The fifth index, as you can see, we have to return the particular index where the particular target is matching that. If particular element is not present inside the array, what we can do, we can simply return -1. That's what mentioned under the note. And we should ask the interviewer what are the constraints of the given problem, and few follow-up questions like what will be the max size of an array, and what will be the maximum value of a particular element, and the target element also. These are the follow-up questions we have to ask to the interviewer if the constraint is not mentioned. If it is there, then we should look at the constraint to get to know which algorithm is best suited for this algorithm to achieve the to run successfully in the servers, online search compilers as well. The size of an array will be starting from 1 till million 10 power 6, and each element of starting from 0, and it also ranges towards a million, which means that individual elements also starting from 0, and it will go up to the minimum. And the key target element will be starting from 1, not from 0, and it goes towards 10 power 5, nothing but 1 lakh. And yeah, and while coding up, you should communicate the interviewer like what will be your approach and what algorithms you are using. And always my suggestion is to use a Navi approach or a brute force approach, and start communicating your intuition, how you want to solve this problem, and start coding up. That's how you can deal with an interview to crack an FANG or NAND company. And I have designed one uh, notes for you to reduce the time and you can get more intuition out of it. Okay, this is my personal notepad and I have started today itself, and then yeah, I have taken sample examples. Basically, this is an example of sorted array. I have taken 1 to 5, couple of numbers, and then I was rotated with the 2 steps towards the right, and then we can see the rotated sorted array was formed. And then I will be starting with the brute force approach. You should always start with a brute force Navi approach. And we can use an algorithm called linear search. Linear search is nothing but traversing every element inside the array and checking every element if it is matching with the target element or not. If it is matching, then simply return that particular index itself. And otherwise, the particular target element was not present inside the given array, you can simply return that -1, which is not found. Yeah. This is Java code, simple, pretty straightforward. Yeah, this is an array list was given, but you can take a primitive versions of int array, and you can do that. This array list is an implementation class inside the list interface, and which will be stored inside the heap area under the main memory. And all the primitive versions and variables are stored in stack memory. That's also key factors while compiling and do the fast processing and improve the improvement of the code, particular piece of code. Basically, it's kind of in a linear traversal starting from zero index towards the end. End is nothing but the length of an array, and checking each element whether it was matching to the target element or not. And then let me take a yeah, highlighter, and we can return that particular index also. If it is not present, we can return -1. And this is the Python code. You use the list, and then this is then a C++. This is then a standard library, standard for competitive and standard namespace using. And you can use vector. Vector, it will store heap area and answer the main memory. And you can simply iterate from the 0 to towards n length of an array, and then check for each element and returning if it is found, and if not, we can return -1. And time complexity of this algorithm is size of an array. We are traversing each element and we are iterating towards, and then constant of an auxiliary space. We are not using any additional spaces except the variables which will be stored inside the stack memory. It doesn't include as an additional data structure, additional spaces. We are not utilizing that. You can communicate. You have to justify your statements. We are not using any particular data structures, which kind of simple variables present inside the stack memory. It will be holding, and inside the main memory, it will be storing. That's how you can justify. And then uh, we should communicate the second approach. Then interviewer will ask a few follow-up questions. Can you optimize this particular piece of code? Then you can simply say how you can identify the particular algorithm as the given question stated that sorted and ascending order. As we know that which algorithm comes in your mind, binary search, because binary search it works on sorted things, and which is an ascending or descending doesn't matter, but it should be and sorted in nature. So the binary search is the best suited, and you can check this constants also. Another hint, 10 million. How can you compile a huge amount of data within within a second? Then we should choose an log of n algorithm to compile any huge amount of loads of constraints or any test cases. You can run within a second. That's how we are we are taking algorithm and deciding on algorithm and start designing and implementing that. How we can design that with the help of modified binary search, with the help of few observations and a few test cases to make a dry run, to make comfortable with that, and then you can do that. Target element is 8 as it given. This is the target element. This is the basic given array, rotated sorted array. And how you can do that? Perform simple, taking the pointer, low pointer starting of the node, and high pointer end of an array, and mid pointer will be the low plus high by 2. You should always use bitwise operator to avoid integer overflow. This is an right shift operator by 1. Uh, how you can do left plus right by 1, right shift by 1, which internally does nothing but to divide by 2. But integer, when it comes to huge numbers, 10 power 9 plus 10 power 9, the integer overflow will happen. Then your problem doesn't work out. It gives an unexpected results. So you should use bitwise operator. This is the trick one. And trick two will be like left plus right minus right minus r minus left by 2. This is another approach. Like you are taking left portion and you are dividing by 2. So this also will not occur any to avoid the integer overflow. That is trick two. And you will be starting with an approach like algorithm how we are going to perform. Initially we took a low will be starting node and high is the endpoint as I discussed earlier, and then taking the mid with the help of right shift operator, and then we have to check particular mid element is matching the target. No need to check for the left portion or right portion. We can simply return that particular mid is the index is we are looking for the target element. And then if that is not present inside that, we can check for the identifying the sorted halves. Like if the sorted half in the left portion, you have to check left portion. Otherwise, it is in the right half isn't sorted. Then you can check here. Uh, I'll be going with this is a C++ code. This is the Java code, and we should start from 0 and till the right pointer and of an array. We should use while loop always, because while loop is the one of the looping statement to execute till the condition matches, till this crossover will happen. This will be executing, iterating towards it will be iterating, and we will be taking left. This is the trick 2, right? As I mentioned, left plus right minus left by 2. This is the trick 2. And trick 1 will be the left plus right shift by 1. This is the trick 1. Using always bitwise, it doesn't overflows. This is the trick 2. And we are checking for the mid element. If it is matching, return that index. If not, we have to check for the left half position, which is in sorted. We are comparing the left portion array of left index and comparing towards mid. If it is an sorted fashion, then we have to check these conditions, uh, like the particular key should be greater than the left half, and this particular key should be lies between the mid, which is nothing but left to here. The diagram left, we are checking the target element 8, right? So we are checking the low pointer and the midpoint. The target element is greater than the low, and it should also check for the this condition also, uh, the mid element also. So this is here mid pointer is less, right? So it goes to here the target element. Given that we are checking here the low pointer, which is nothing but 7, and the target element is 8. Yeah, the condition is satisfied. 7 is always less than 8, and 8 should be less than mid. It should be less than mid. If not, then it goes to here. Low equal to mid plus 1. It goes to here. We will be checking. First of all, it will check this condition, right? Low pointer and mid pointer, if both are sorted or not. This is not sorted. As you can see, 7 is not sorted, not less than 2. So it fails the condition here itself. We are checking left part is sorted. If the left part is sorted, do this operation. If the right part is sorted, do this operation. So in this case, left is greater and 2 is smaller, which is not, this is not a sorted. Here we can identify that this is a sorted. So this is the else case. You can see that I wrote here right part is sorted, as we know that particular our test case is right part is sorted. I was checking the mid element should less than k, and k is less than the high. Same thing should happen here. Mid is 2 and target element is 8, which is not satisfying the condition. There itself fail. Here this condition will fail because k is greater and array of mid is 2 is passing, and here itself fail because k equal to 8 and high value is 6, so it doesn't succeed. So how it works, then it goes to here. I is equal to mid minus 1, which is nothing but you are shrinking the right half, which is not present inside this portion right half, and it will check here in the left of portion, and the loop will again condition will check whether low is high. It is not a crossover, so we will be checking inside this particular range, and inside this range it will follows under the left half, and then it will check here 1 and 7. This is also failing the first condition, which is not a sorted order, and it goes to the left portion and check the mid array of mid element and the particular k. If the particular number exists, then it will choose the low equal to mid plus 1. Here it doesn't satisfy. Again, it goes to left and it will shrink. The same fashion will go on until it reaches the particular element. So at the end, we will get 8 as a 1, it will low pointer will towards shifting towards 1, and the right pointer will shrink until it reaches to the same pointer. At the end, we will get uh, mid equal to low plus high by 2. So we are checking the mid pointer, right? We will get in a target node and we are returning the particular index. That's how it works internally. We are checking two positions with the help of three pointers, and which is sorted. This portion is not sorted, which is if this is the sorted. We are performing binary search operation. If it's not, we are checking for the right half and shrinking the sizes, shrinking the left portion and right portion. If it is not suited, that's all. And I will be executing this piece of code to justify whether it was working or not. Yeah. This is Java code, Python code also same. Tom, mm, let me copy paste. Yeah, let me execute that. Let's see will it work or not. See, it was running all the test cases. All are fine. As you can see, the current strike is 322 days. All are done, and that's all. And coming to the time complexity, we should discuss this time complexity. We are using binary search, like shrinking the left half or right half, based on the conditions. So it is taking on average and was time complexity of login only, which is n is the size of an array, and we are using binary search to find the target. And we are not using any auxiliary space, and we are using only the variables, three variables which will be stored in a stack memory. It doesn't store in heap, and there is no space out of it. That's how we are adjusting. And we should not include the given input array as well. Yeah, that's all. Yeah, thank you. Like, share, and subscribe, please.